Culvert replacement is one of the most critical and complex maintenance tasks an Ohio DOT highway technician, or HT, performs. It impacts roadway safety, stormwater management, and long-term resilience. Culverts are rated during inspections using ODOT's 1 to 9 scale. Lower ratings mean higher urgency for repair or replacement. ODOT inspectors evaluate barrel integrity, joint separation, end treatments, corrosion, undermining, and blockages. Inspections usually occur in the fall when the culverts are more accessible. Crews may enter the culvert, use cameras, or inspect from the ends, depending on culvert size and condition. Culverts rated 4 or below are prioritized for replacement, particularly if the roadway is scheduled for resurfacing. Culverts rated 5 or 6 should also be considered if there are signs of deterioration or poor drainage. Successful culvert replacement starts with pre-planning. Months in advance, the site must be visited to gather field data and identify potential issues. During the pre-planning visit, verify the culvert's condition and rating, confirm inspection results, note issues like cracks or joint separation, and how surface water is flowing through and around the area. The HT, who will act as crew leader on the job, should also evaluate access routes, terrain, and environmental constraints in conjunction with their county managers. For wetlands or regulated areas, coordinate early with environmental staff or regulatory agency. Measure and record the existing pipe's depth, diameter, length, material, and condition. Document inlet and outlet inverts for hydraulic review and trench planning. Coordinate with the hydraulic engineer to confirm the pipe size and any design changes, like half-height head walls. During pre-planning, it may also be necessary to collect ground elevations 100 feet upstream and downstream. Identify fixed objects, such as pavement edges or utility poles, to use as benchmarks for checking flowline elevation, trench depth, and clear cover, the distance from the top of the pipe to the finished surface. Required clear cover varies by the type of pipe and ranges from 12 to 27 inches. If clear cover is insufficient, consult the engineer to develop an alternate design that meets structural requirements. Measure trench depth and width to decide between trench boxes or sloped walls. Slopes must have at least 1.5 foot horizontal run for every 1 foot vertical rise. For extra safety, some districts use a 2-to-1 run to rise ratio. Confirm the dump site before excavation. All spoils, soil, asphalt, and pipe must go to an approved location. If plans change, pause and verify the new site is approved. Look for nearby streams, wetlands, or protected areas. If impacts are possible, submit an environmental review form early, up to 6 months ahead, and contact ODOT's Office of Environmental Services. Plan the work zone layout to safely accommodate equipment, spoils, materials, and vehicle access, while maintaining at least a 2-foot buffer from the edge of the trench. Pre-mark the location of barricades at least 500 feet in advance, taking care not to block nearby crossroads or driveways. Keep all equipment and materials within the ODOT right-of-way. Scheduling a culvert replacement isn't just about picking a date. You also need to plan for materials, schedule deliveries, reserve equipment, and coordinate your crew. Here are some considerations for choosing the right bedding and backfill. For damp bottom trenches, number 57 limestone is often a good choice. It drains well and can be shaped easily with hand tools like a lute. For backfilling around the pipe and up to the asphalt level, number 304 or number 411 limestone are common options. Number 57 limestone should only be used if groundwater is present in the trench or seeping through the trench walls. When number 57 limestone is required, make sure it is properly compacted and wrap the trench with geotextile fabric to keep surrounding soil from migrating into the aggregate voids. In most cases, you will not know that number 57 limestone is necessary until after the trench is excavated. But in narrow trenches, or when the schedule is especially tight, low-strength mortar LSM or a controlled density fill may be the better choice.
It's not as cheap as putting in the aggregate, but it saves you a lot of time. So if you can get in 2 or 3 pipes by using LSM and a narrow trench with a trench box, then that might be the way you want to go, depending on what your season looks like. It's all stuff you got to talk about with your engineers and with your county management.
Plan equipment needs based on pipe size and trench dimensions. Schedule large excavators or trench boxes early, especially if they are shared district-wide.
You don't want to get out there and find out the hole's deeper than you thought, and now your excavator can't reach. You're overreaching. You're tipping because the excavator, the farther reach you got, the more of that changes your load. So you want to have all that stuff pre-planned before you ever come out.
Special equipment such as hoe rams or jackhammers may also be needed.
We do a lot of planning, but we can't see what's actually under the road. So we find old structures, old head walls. We've even found old bridge abutments, stuff under the ground. In this example, this head wall, they had no idea the head wall was in there until they were digging the old pipe out and found an additional one from where this road was widened, several years ago. So you find those surprises underground, and the crew, part of having the experienced team on the crew is they can adapt and adjust when those things are encountered.
Another important resource to schedule is your crew. Assemble a team with a good mix of experienced staff and assign a competent person trained in trench safety and OSHA compliance. A competent person is someone who can identify existing and predictable hazards and is authorized to correct them. Safety is paramount during culvert replacements. An important step in the pre-planning phase is to determine which trench protection method to use: sloping, shoring, or a trench box. These methods must follow OSHA standards.
We can't use benching in Ohio because of the type of soil we have. Benching would be like a stair step. That's an approved method of OSHA, but it's not applicable here. Sloping, we mainly use sloping or trench box. The sloping is where we run it at 1.5 times the depth back at an angle, and that keeps the sides of the excavation from caving in. Not 100% foolproof, but that angle seems to be pretty good. And then trench box will actually shore up inside the excavation. It's convenient for the trench box. You don't have to dig as deep.
Utility clearance is another critical step necessary for planning a culvert replacement. The Ohio Utilities Protection Service, or OOPS, must be contacted 48 hours to 10 days before digging. While official locate requests must fall within that window, early planning calls can uncover conflicts, like gas, water, or fiber lines, helping avoid design issues and delays. The HT should verify utility markings are on site and ensure the crew knows where it's safe to dig. Photograph utility markings before you dig and include fixed objects, trees, poles, pavement edges, and items that show distance. These photos can prove mismarked lines if a strike happens. If there are overhead utility lines, the utility company may need to install protective shielding around them. If work is delayed beyond 10 days, a new request must be submitted to keep markings accurate. Coordinate detours with the district office and check for roadwork or event conflicts. Communicate closures early. Post 10-day warning signs, counted in working days, on site with the scheduled closure date. Send a formal email to your district detour coordinator at least 14 days before the closure. Once detour signs are posted, they cannot be moved, so plan staging and work zone access carefully. Solid pre-planning, guided by established ODOT practices and the crew's field experience, help ensure project success.